welcome back everyone. We have 5.5 rational equations, and we are just going to pretty much be diving right into this. All right, our two learning goals are to solve rational equations and to identify extraneous solutions if there are any. Okay, now here's your first problem. Okay, and again, we're getting right into this. Okay, when solving rational equations, you're going to notice that they look much different than a regular equation. Obviously, we have rational expressions with variables in our denominator's place. Now, instead of listing kind of steps, I'm going to list goals. And I think this is a good compromise. Your first, because obviously, as I've mentioned many times, I don't like steps because they kind of pigeonhole you. But a good first goal is to rid the denominator of variables. Okay. Now, I know this may not seem any different than a step. Okay. But when you write steps, you more like, hey, use the property of equality to, do this, or do reverse order of operations when solving equations. They're much more pigeonholed. This is a general guideline. You're going to see that we can actually get rid of variables in the denominator's place in many different ways, okay? But that's the first thing that we want to do. Now, looking at this expression, 8 divided by x minus 2 is equal to 4 divided by x. The way that we can get rid of those denominators, those variables in the denominator place, is by doing the opposite, right? We're dividing by them. So let's multiply by them. So I'm going to multiply, I'm going to go to this one, I'm going to multiply the top by x minus 2 here, and this top by x minus 2. Now you may be thinking, well, how can we do that? Well, if I had something as simple as, let's say, doing this over on the right here, if I had x divided by 2 is equal to 7, right, you would multiply 2 to both sides. We're doing the same thing here, but with the x minus 2. And what that would do is it would officially get rid of it in the denominator's place. Now it is in the numerator of the other side, but that's fine. Okay, and now we still have that variable on the right side. We're going to do the same thing. I'm going to multiply this side by x, and I'm going to multiply this side by x. Okay, so put those multiplication symbols. All right, and what that does is it rids it of the denominator on this side, and now it's in the numerator on the other side. Okay, so let's simplify this out. We end up with 8x is equal to 4 times x minus 2, and then we have a times x again. That's kind of positioned kind of weird, but that's okay. Let's distribute this. That's going to be equal to 4x minus 8, and all of this is times x. Okay, that kind of looks awkward. Let's do this a different way. Okay, let's times the 4 and the x first. So we get 8x is equal to 4x times x minus 2. And then we'll distribute the 4x in here and here. So we end up with 8x is equal to 4x squared minus 8x. Okay. Now we need to solve for x. Okay. But we, can kind of put a check in the box for our first goal. We rid the denominator of variables. Okay. And so that's where goal number 2 comes in. All right. Let me erase this. All right, goal number 2 is to solve for x now. Okay, so let's do that. Let's go back to our problem here. Now, in order to solve for x, we need x by itself. Okay, and you can see that we have a power of 2 in this problem, which is not going to happen in every problem, but it will happen in a lot of them. All right, so I'm going to try and get that x squared by itself. I'm going to add 8x to both sides. This cancels. I get 16x over here. Yeah, 16x over here, okay, is equal to 4x squared. So that's not working out for me, okay? Let's go back here. Let's go back a step. And this is something you're going to kind of see happen a lot, all right? You're trying to solve for x. There's a lot of different ways. Let's move this and let's set it equal to 0 and kind of use some of those quadratic style things that we figured out. Okay, so let's minus 8x here, minus 8x here. We get 0 is equal to 4x squared minus 16x, okay? And now I can see that I can factor out a greatest common factor out of these. Both of these can take 4x out of them, like this. And that gives me 0 is equal to 4x times x minus 4. Okay? And now I'm actually able to figure out what x is equal to. All right? And this is really kind of going all the way back to quadratics, right? We can use that zero product property, where if we assume 1 is equal to 0, we can solve for the other. So I'm going to assume x minus 4 is equal to 0. So I'm going to go 4x is equal to 0. And I'm going to assume the other one is 0. I'm going to go x minus 4 is equal to 0 and solve for them both. The first one we get 0. And then the second one, we get x is equal to 4. Okay? Now, let's go back to our original problem here. All right? We said we had two numbers, x is equal to 0 and x is equal to 4. But these are rational equations, which means they're not much different than rational expressions. They still have domain restrictions, right? So if we jump back to our original problem, let me erase all of this stuff up here so we can really kind of see it clearly. Jump back to our original problem, and we evaluate what the domain restrictions would be. Well, the first one we have is x minus 2, so we can't have 2. And then the lone x on the right there means that we can't just have a 0 there. Now, if we follow this to our answers, we said that one of the x's was equal to 0. And now we're saying that a domain restriction is equal to 0. This is what we call an extraneous solution. Okay? An extraneous solution means that one of these substeps that happened here, okay, has x is equal to 0 as the answer to it, but not the original problem. So in the process of getting these variables out of the denominator's place, we kind of made a new equation that had an answer to it that wouldn't exist for our original. Okay? Now you need to keep track of this. Don't just get to the end and go, these are my answers. Okay? Because sometimes that domain restriction is going to say one of them is not really it. So what's our final answer? X is equal to 4 is our final answer. Put that there. Okay. Now, that was a lot of work, and this is one of the smaller rational equation problems, but you have a good set of goals. Rid the denominator of variables, solve for x. Okay? Let's do another one. This one's a little bit longer, all right? And we have some more terms in here. We have a 1 minus 8 divided by x minus 5 is equal to 3 over x, okay? And we're actually going to do the same exact thing here, all right? We are going to, turn that off. We are going to take our denominators and multiply them to both sides so that we can get rid of them in the denominator's place. Now, when I take this x minus 5, though, and this is where things get tricky, is I can't just multiply it once, right? It needs to multiply by the 1, and it needs to multiply by the 8 over x minus 5. And so I'm going to multiply it in two places, okay? So I'm going to go x minus 5 here, x minus 5 here, and x minus 5 here. Okay, now this is all multiplication. So x minus 5 times the 1, x minus 5 times the 8 over x minus 5, and then x minus 5 times that whole side. Okay, and this is the thing with multiplication. This is very common, right? If we multiply, to each side, we're multiplying to everything on that side, not just one of those terms. Okay, so we see here the x minus 5s will cancel, but it's going to be left in on that 1, and that's okay because that'll be in the numerator's place. All right, so this is a little bit longer of a problem. So before we do any more here, let's simplify. Let's take our x minus 5 times 1, which just gives us x minus 5. All right, and all of that is being subtracted by 8, which is then equal to 3 over x. Well, let's do it this way. 3 times x minus 5 over x. Okay, seeming complicated yet, right? Now, you don't have to simplify here, but I want you to see that we did work out one of these x minus 5s. You could have just written it, now I'm going to take the times x and the times x and the times x up here. But as you can also see, that's kind of messy too. Okay, so I'm choosing to kind of, take the work that I've already done so that now we can multiply everything by x. Okay, Now, let's simplify this on the left though, right? We have an x minus 5 minus 8. We can drop those parentheses, and we're really left with an x minus 13 is equal to 3. You know what, let's simplify that too, so that we don't have to deal with these things later, right? Let's bring that in, and we get 3x minus 15 over x, okay? So now we multiply by x, we multiply this whole side by x, this cancels, and you see we're gonna have to distribute this in. So we get x squared minus 13x is equal to 3x minus 15. That's a lot, right? Okay, goal 1 though is done. All the variables are out of the denominator's place. Okay, so let's focus on solving for x. Let's get all of our terms to one side. Let's minus this 3x. Let's minus this 3x here. And then in the same time, I'm going to add this 15. And I'm going to add this 15 here. So it cancels here, cancels here. And we're going to be left with x squared minus 16x plus 15 is equal to 0. All right, kind of like a quadratic again, right? It's looking like we can use that diamond method. So we get 15 up top, negative 16 on the bottom, and then 15 times 1 is 15. 15 plus 1 would be 16, but we need a negative, so we'll make both of these negatives so that they still multiply to a positive, which means I have x minus 15, and I have x minus 1 as factors, which would make x is equal to 15 and x is equal to 1. Now, we still need to go back though and double check here. We have domain restrictions. We have a domain restriction of x cannot be 5. And we have a domain restriction of x cannot be 0. Now, neither of these cancel out this, okay? So we do have two solutions. It's x is equal to 15 and x is equal to 1, okay? Now, to jump back here, I want to kind of notice that this one went a lot smoother, right? You know, we got down to here. It was kind of clear that we could use the quadratic. When I first looked at this step back here, and I was right here, I started to think to myself, or excuse me, a little bit higher, right up here, that maybe I'd end up in a kind of a square root kind of a situation to both sides, but I didn't. And I left that error in instead of restarting the video because I want to see that when you get to solving this, there's going to, you know, all sorts of the ways that you have learned to solve for x are going to come to play. Lots of different types of factoring, right? In this one, we ended up factoring the greatest common factor. In this one, again, we ended up factoring using the diamond method. It's the same as all these previous methods. Factoring, 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 factoring. Okay. This one's for you to do. So why don't you guys give it a pause and give it a try, and then I'll go over it. Okay, so hopefully you gave this one a try. All right, this one looks a little bit different than the previous problem, all right, but it's the same thing that applies. We're going to take this x minus 1 and multiply it to both sides. It's going to cancel out here, and now it's on the right. We're going to take, I'm just going to do this at the same time, the x squared minus x to both sides, and it's going to cancel on this side. And I'm going to be left with 2 times x squared minus x is equal to 6 times x minus 1. I distribute for both of these. I get 2x squared minus 2x is equal to 6x minus 6. I've successfully done the first goal, right? Everything is out of the denominator's place, at least all the variables are. And now we need to solve for x, so let's get all our terms to one side. And I'm choosing to take this to the side that already has x squared on it. It's going to cancel there. I'm going to add 6 to both sides. And I'm going to get 2x squared minus 8x plus 6 is equal to 0. Now, we need to solve for x. I know we can do the diamond method, but right now we have an a value that's not 1. Makes the problem a little bit more difficult. So I'm going to rid. It looks like we can factor out a greatest common factor here to not deal with it. And so we get this. And then we can do the diamond method. We put a 3 on the top, a negative 4 on the bottom. 3 times 1 is 3, but not negative 4, so we make both of these negative. So negative 3 times negative 1 is positive 3, and then negative 3 plus negative 1 is negative 4. So we can write those as our factors. And we get x is equal to 3, and we get x is equal to 1, okay? Now, I know I'm kind of brushing through a lot of these steps, but we spent units on that kind of stuff, okay? Now, let's jump back to our domain restrictions up top. Domain restrictions, okay? Looking at this first one here of x minus 1, means that x cannot be positive 1. And then looking at our second one here, we have an x squared minus x, okay? That doesn't really help us too much in our domain restrictions, right? So if I separate that, I get x times x minus 1, like that. And now that x minus 1, we already dealt with a domain restriction from that, but we're also going to have x cannot be equal to 0 because of the lone x. Now, if you're tracking here, the x is not equal to 1. We have an x is equal to 1 in our answer, so we have an extraneous solution. So our final answer is x is equal to 3. Okay. All right, so hopefully you got that one. Let's do some different types, okay? Because there's lots of different types. Here, we just have one that's, not on both sides. That's okay. Same exact thing applies. We just have to do a little bit less of it, okay? So I'm going to times x to both sides. I'm going to times x to this whole side. It's going to cancel out here. And we're going to get 2 is equal to x times x minus 1. I distribute. I get 2 is equal to x squared minus x. Okay? Awesome. Now, we're good on the first goal, right? We don't have a variable in the denominator's place. We're going to get everything equal to 0. So we get 0 is equal to x squared minus x minus 2. And we're going to do our x factor. We have a negative 2 on the top. I'm getting some weird static. I don't know if you guys can hear that. We get a negative 2 on the top. We get a negative 1 on the bottom. All right. 2 times 1 gives me 2, but I need one of those to be negative, and I need my addition to be negative, so it's going to be a negative 2, because negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So I have these factors of x minus 2 times x plus 1 is equal to 0, meaning x is equal to 2 and x is equal to negative 1. Now, looking at my extraneous solutions, there's only a single x. Looking at my domain restrictions, there's only a single x in the denominator's place, so x cannot be equal to 0. That means both of those answers at the bottom are good because there was no domain restriction for them. Okay, let's keep going. Oh, that was a you-do? Darn. Oh, missed that one. Oops. Okay. Well, now we have a really long problem, much longer than the previous one. That's okay. All right. Now, this is again why I don't like listing goals here, okay? Because now the goals have kind of changed. I mean, they haven't changed, but they have a little bit. Our first goal, like we said, was to rid the, denominator of variables, okay? So I guess the goal is still good, but the steps on how to do this have changed. We have a different set of steps to do this one, or at least a different way of starting before we get to the same steps. If I had written just steps, if my first thing was, hey, multiply both sides by the factors, this would be incorrect here, okay? Before we do that, need to get this trinomial here into factors, or else you're going to have to multiply this to both sides, and you're going to have to do a lot more math than you're going to want to, right? And let's break this down. Let's see this. Look at this, x squared minus 7x plus 12. If we factor this first, we have 12 on the top and negative 7 on the bottom. We end up with, let's see, what? A negative 4 and a negative 3. Negative 4 times negative 3 is power 12. Negative 4 times, add another 3 is negative 7. Good. Okay, let's rewrite our problem here now. 17 minus 3x divided by our factors of x minus 4 times x minus 3 is equal to x plus 1 over x minus 4. Now, if you look, wait a minute, there's an x minus 4 here, and there's an x minus 4 here, okay? That kind of changes the situation a little bit here, right? If I multiply with just that one, it cancels out on both sides, and it ends up in the numerator in no places, okay? Well, that took a lot out of our problem here. That took this huge problem here and eliminated completely a lot of work out of this problem. If you would have started off the same way of multiplying this to both sides, you would have had to do a binomial times a trinomial, and it would have taken you many, many steps before you realized that you could have just gotten rid of that x minus 4 off the bat. Our new problem here now is 17 minus 3x over x minus 3 is equal to x plus 1. Much, much shorter, okay? So the goal is still good. We're still trying to rid the denominator variables. Just have a different set of steps, okay? Really trying to nail it home while I don't write steps, okay? Now, we're going to times by x minus 3 to both sides like we would have. So we're going to have binomial times a binomial here. It's going to cancel. And now I have 17 minus 3x is equal to, and let's distribute that, x times x minus 3. We get x squared minus 3x plus x minus 3. We simplify, and we're going to get 17. Let's zoom in a little bit here. 17 minus 3x is equal to x squared minus 2x minus 3. Okay, now we want to solve for x. We're going to get all our stuff to the same side. So we're going to add the 3x, add the 3x. We're going to minus the 17 minus the 17. If you notice, I'm doing those at the same time because why not? Why have to do them separately, right? We get 0 is equal to x squared plus x minus 20. All right, we do our x factor. We get negative 20 on top, a 1 on the bottom. So, oh, this is a good one, right? 5 times 4 is 20, and it has a difference of 1. So we know we have the right numbers. We just have to play around with the negatives, and it's going to be 5 minus 4 is 1, and 5 times negative 4 is negative 20. So we get x plus 5 times x minus 4 is equal to 0, which means x is equal to negative 5, and x is equal to positive 4. Now let's jump back to our domain restrictions. Okay. And when we look at our domain restrictions here, from, kind of looking at the original problem, we have an x cannot be equal to 4. And we have an x cannot be equal to 3. And I hope you're seeing right here that these line up. And so our final answer is is negative 5. And it's only 1, okay? And in fact, that kind of makes me feel like we have a third goal here, right? Because I've been doing this in every single problem. Identify extraneous solutions. Okay? All right, where are we? Man, we've done a lot of problems. It's going to be a long video. Okay, we got another I do. All right, here we go. Okay, so, this is a good one. Okay, yeah, this is a good one. So we have 2m divided by m minus 1 plus m minus 5 over m squared minus 1 is equal to 1. We have the same goals. We have to rid that, those factors in the denominator's place. But before we do that, we do have a little bit of factoring we can do right here to see if we have another factor that looks like m minus 1. And we actually end up having that. So we still have 2m over m minus 1 plus m minus 5 over difference of squares, m plus 1 divided by, or times m minus 1. Okay. And then all of this is equal to 1. Now I'm thinking maybe we could simplify just this first. I mean, we could times. Yeah, no, we could do this one of two ways, right? We can sit here and we can go, well, the only thing that's missing from these denominators to make them the same is that this one doesn't have an m plus 1. So we can multiply that m plus 1 over here, do up this math, right? But let's keep it how we're doing it now, okay? But there is many ways to solve a problem, right? Hence avoiding steps. Okay, so let's multiply first m minus 1 through the whole problem. So let's go m minus 1 times m minus 1 times m minus 1. And we're going to simplify. Cancels. Okay. Here we're going to have 2m plus, what, m minus 5 over m plus 1 is equal to, and that's just m minus 1 on that side. Okay. Now we need to multiply by m plus 1 And you can do these at the same time. Okay, just kind of how I was doing with the solving equations. I was adding and subtracting, or multiplying, dividing like twice at the same time. You could do this all at the same time. You could just quickly identify here and just write them all up on the top. But I'm trying to keep things just a little organized chaos here. Okay, so this cancels. We're going to have to distribute here. Okay, so we end up with 2m squared plus 2m. Plus, we have our m minus 5 is equal to, we need to double distribute, m squared plus m minus m. Oh yeah, kind of a difference of square situation there. Minus 1. Those are going to cancel. These are going to simplify together. And so we're going to get 2m squared plus 3m minus 5 is equal to m squared minus 1. We get everything on the same side. So we get a minus that m squared here. We're going to add that 1 there. Cancels equals 0. And we get m squared plus 3m minus 4 is equal to 0. We do our x factor. We get a negative 4 up top, a 3 on the bottom. So we must have a 4 and 1. And making that negative 1. So 4 times negative 1 is negative 4. 4 minus 1 is 3. We write out our factors. We have m plus 4 times m minus 1 is equal to 0, meaning m is equal to negative 4 and m is equal to positive 1. So those are your two answers. Now we're going to go back. We're going to look at those domain restrictions, okay? And you see that we had a plus 1 and we had a minus 1 here, right? So m cannot be 1 and m cannot be negative 1. Hopefully you're seeing that, oh, not that one. You're seeing that extraneous solution. So m is really just negative 4, okay? Dang, how many problems I put in this? Holy guacamole, okay. All right, you know what? Better to have more problems than less problems, okay? Especially since there's a ton to do here. Wow. Okay, all right. We're at the end is nigh, okay? All right. Here we go, okay? So we got a k minus 2 here, a k minus 6. I'm seeing that we have a trinomial here. In order to work out this equation, let's factor this, okay? So we got a 12 on top, a negative 8. So that would be what, 6 and 2? And they both need to be negative, okay? So we're going to get 4 over k minus 6 times k minus 2 is equal to k divided by k minus 2 plus 1 over k minus 6. Now you kind of already can hopefully see that this looks like a very long problem, but look at how we have pretty much all the same factors in the denominator's place. So when we multiply, and let's do it all in one step here. Watch this, k minus 2 and k minus 6, right? Because those are the two factors, this one and this one. And we're going to do it for this one. So k minus 2 times k minus 6. Okay. And we're going to do it for this one over here. K minus 2 and k minus 6. Watch how quickly this will cancel out. K minus 2, k minus 6 cancels. The k minus 2 cancels. The k minus 6 cancels. Now, hopefully you can kind of see why I avoided doing it like this. It's hard to see what's left, but we have a 4 left here. We do have a k here and a k minus 6 there. And then we have a 1 and a k minus 2 left. So let's write that out. We have 4 is equal to k times k minus 6 plus 1 times k minus 2, which is really just k minus 2, right? Now we can unravel this. We're going to get 4 is equal to k squared minus 6k plus k minus 2. And now you can kind of see we're on our way to simplifying and solving for k here, right? So those simplify. Let me write this off to the side here. And let's also subtract our 4. So we get 0 is equal to k squared. What's that going to be? Minus 5k minus 6. We have a negative 6 on top, negative 5 on the bottom. So we're looking at 2 and 3. Ooh, what's going on here? Okay, let's take a step back here. All right, because we got a negative 6 here. 2 times 3 is negative 6. One of these needs to be negative. Yeah, I chose the wrong numbers. Okay, we're going to need like a 6 and a 1. Yeah, and here's kind of a clue, right? This bottom number should be the difference between these two numbers, all right? Like the absolute value difference. If this is a 5, 6 and 1 has a gap of 5. That's crucial. That's needed. And if you jump back, you can see that in all these, right? 3, 4, and 1, the difference is 3. You jump here, look, 4 and 3, well, this one is the sum of them. So it is sometimes the sum or the difference. Excuse me. All right. Now one of these needs to be negative. It's going to have to be that negative 6. And so we get k minus 6 times k plus 1 is equal to 0, meaning that k is equal to 6 and k is equal to negative 1. Now, let's jump up and look at our domain restrictions again. We have a k cannot equal 6. We have a k cannot equal 2. So hopefully you're identifying the extraneous solution here. Okay? So our only answer is k minus 2. Okay? All right. Last one. This one's for you guys. Give it a try, and then we'll go over it. Okay. So hopefully you gave this a try. Hopefully you started off by factoring this out. Okay? And then going on to your next step. All right, so we have x over x minus 2 minus 1 over x minus 4 is equal to negative 4 over, well, let's do that diamond method, 8 and negative 6. All right, so we're looking at like a 4 and a 2. So 4 times 2 is 8. But they're both going to need to be negative so that the top stays positive and the bottom becomes a negative 6. So we get x minus 4 times x minus 2, which looky, those are our other factors. So this is going to kind of work out for us. So we're going to do the x minus 4 times the x minus 2, and the x minus 4 times the x minus 2. We're going to go all the way across and do both of them, okay? And we're doing that because they're both in here. They're both right here, okay? So if we would have done this individually, we would have ended up putting an x minus 2 in all three of these terms, and we would have ended up putting an x minus 4 in all three of these terms. So we're just taking a shortcut now that we've been doing this a little bit longer, okay? All right. So the x minus 4 is canceled, the x minus 2 is canceled, this x minus 4 cancels, this x minus 2 cancels. Okay, so we're left with x times x minus 4 up top minus 1 times x minus 2, which is just, let me just actually jump back here and make sure. Now we had addition in this one, so it wasn't an issue, okay? And what I'm trying to bring up with is right here, okay? So, it's a plus here, right? And so in this last problem, I was like, oh, it's just 1 times k minus 2, right? And so I was easily able to jump down and say plus k minus 2 because it's a plus. It doesn't change that this is a k and a negative 2, right? But this problem is a negative, which means this negative is going to all of this x minus 2. So we're going to have to keep this in parentheses. And to take it out of parentheses, we have to distribute that negative, okay? All right, and all that will be equal to negative 4, all right? So we're going to distribute both times here. We get x squared minus 4x minus x plus 2 is equal to negative 4. We want to get everything, I don't know why I did that. Everything equal to 0 and simplify. So we end up with x squared minus 5x plus 6 is equal to 0. We do our diamond method. We have a 6 and a negative 5. Okay? So again, look at that. We need a difference of 5, so 6 and 1. And that will be... Oh, do we got another issue here? Looking like it's the sum this time. So, man, not my strong suit here, huh? So negative 2 times negative 3 is positive 6, and negative 2 times negative 3, negative 2 plus negative 3 is negative 5. Okay. All right, so x minus 2 times x minus 3 is equal to 0. So that means x is equal to 2 and x is equal to 3. We go back, we check our domain restrictions. We only have a domain restriction of x cannot be 2 and x cannot be 4. And hopefully you're tracking on the extraneous solution, which you're starting to see in a lot of these problems. Okay? And that means that only x equals 3 is our final answer. Okay. Now, this is a lot, you guys. All right, it's a lot in a single problem. You know, tried to let you guys know at the beginning of the semester, right? It's gonna get harder in semester 2 of Algebra 2. Okay, nothing in here is unattainable. Okay, let's just revisit the goals and then we'll wrap this video up. Okay, rid the denominator of the variables. Okay, a lot of times that means just multiplying by whatever's in the denominator to everything, or sometimes that means you're gonna have to factor this before you can do that. Now, if you're like, oh man, I gotta factor it first, that's so much extra work. A lot of the times, as you see, you know, we had x minus 4 there, it ends up with the same factors. It actually will make your life easier, okay? And then after you do that, you solve for x, okay? And then you identify extraneous solutions, okay? And by identify them, you don't need to sit there and go, oh, here are my extraneous solutions. You need to make sure those don't make it into your final answer, okay? All right. So I did kind of have a math talk here about how equations kind of open doors to solving problems. And I had this, I don't want to take too much time up on this, but largely think of this, okay? This is a real equation. All right, W is equal to RT, work is equal to the rate of work and the time spent working, okay? Now, before Algebra 2, you might have thought that this is going to happen, that someone's going to go, well, R, the rate of work is, 3, and they give you some units, right? And the time is, 4, and they give you some units. And so then your work is 12, okay? But now we're getting to the point, and this is really going to happen a lot in pre-calculus and calculus, where R can be equal to an entire equation, maybe a rational expression even. And T could be its own thing. And so now we're working with maybe, multiple equations being brought in. Some of them are rational. We're unlocking doors to solving, the problems that need to be solved, the new frontier problems, not the problems of the past, which is a lot of Algebra 1 where you sit there and you go, oh, we sold 12 candy bars and, we had to spend $80 to get those candy bars. So what is our profit, right? Like those are the problems of the past. Now we're starting to get to the stuff that helps us solve the problems of the future. Okay, so hopefully you guys made it through here. I'm going to end the video. Have a great night, you guys.